In this video, we are going to verify Stefan's law by electrical method using vacuum diode. The object of the aim is to verify Stefan's law by electrical method. The apparatus that we'll be using in this particular experiment is a 6-volt battery to heat the filament of the diode, a vacuum diode valve EZ81, a DC voltmeter of 0 to 10 volts, a DC ammeter of 0 to 1 ampere and rheostat of 100 ohm. The theory and the formula that we'll be using in this particular experiment is if E be the total energy radiated per second from a unit surface area of a black body at a temperature T surrounded by another body at temperature T0, then by Stefan's law we have E is equal to sigma T raised to power 4 minus T0 raised to power 4, where sigma is the Stefan's constant. For bodies other than black body, the similar relation for the power emitted by the body at temperature T surrounded by another body at temperature T0 is given as P is equal to C T raised to power alpha minus T0 raised to power alpha, where C is some constant which depends on the material and area of the body and alpha is a power very close to 4. P is equal to C multiplied by T raised to power alpha multiplied by 1 minus T0 raised to power alpha divided by T raised to power alpha. If T is much greater than T0, then the above relation reduces to P is equal to C multiplied by T raised to power alpha. Taking logarithm of both sides, we get log P is equal to alpha multiplied by log T plus log C. This equation is a form of straight line equation like y is equal to mx plus c. Therefore, a graph between log P and log T should be a straight line whose slope gives alpha. If alpha is approximately equal to 4, then Stefan's law is verified. Hence, to verify Stefan's law, we have to measure the following two quantities. Firstly, power radiated by the body, and secondly, temperature T of the radiating body. The temperature of the radiating body is determined by using well-known resistance temperature relation expressed as R at temperature T upon R at temperature 273 is equal to T upon 273 raised to power 1.2. Therefore, the operating temperature of the filament is determined by measuring its electrical resistance. Now, moving on to the procedure, firstly, we'll make the electrical connection as shown in the figure and main supply is switched on. Now keep the current at 0 position by adjusting the current control knob at minimum. Secondly, now filament current I is increased and apply some filament voltage Vf by adjusting current control knob one by one at 0.2 volt, 0.4 volt and 0.6 volt etc. And measure the corresponding filament current IF in the ammeter after steady state is reached. For steady state, wait for 3 to 4 minutes before recording the observation after adjusting the filament voltage. Repeat the experiment for sufficient number of set of observation so that a graph can be plotted. Now record each observation in the table. Now let's move on to the calculation after making all the observations. Firstly, power radiated by the tungsten filament for each value of filament voltage Vf and filament current If is calculated as P is equal to Vf and If. Secondly, filament resistance RT is calculated for each value of filament voltage Vf and filament current If as RT is equal to Vf upon If. Now, then we'll find the value of RT upon R 300 Kelvin. Now a graph is plotted between the given temperature of values at temperature T and RT upon R 300 for tungsten with half of the table. From this graph, for each experiment calculated value of RT upon R 300, find corresponding value of temperature T. Now plot another graph taking log t along x-axis and corresponding log p along y-axis. The graph will be a straight line. We'll be finding its slope, which would be about 4. The slope of the curve will be equal to log p upon log t is equal to AB upon BC, which will be approximately equal to 4. The graph between log p and log t is a straight line and the slope of straight line is about 4. Hence, Stefan's law is verified between the experimental error. Now, moving on to precautions and sources of error that we'll be keeping in mind while performing this experiment. Firstly, to get accurate resistance at a particular temperature, the filament voltage Vf and filament current If should be read every time after achieving a steady state, or the time difference between each observation should be about 3 or 4 minutes. Secondly, the slope of the straight line should be determined as accurate as possible.